We're tackling a problem involving GroupShuffleSplit, a tool in Sklearn that helps us do stratified k-fold cross-validation while respecting group structures in your data. This is crucial to avoid data leakage, which can seriously mess up your model's performance. Stratified k-fold cross-validation means splitting your data into k-folds, groups, in a way that preserves the proportion of each class in each fold, making your cross-validation results more reliable. This method is particularly important when you have a dataset with groups. I have a dataset containing 100 samples, data points. These samples are organized into 20 groups, with each group having exactly 5 samples. This grouping is important because we need to ensure that samples from the same group always end up in the same fold during cross-validation. The core of the quiz is to select the correct way to use the GroupShuffleSplit function to create folds for cross-validation. The key constraint is that all samples within a group must end up in the same fold. Let's see which answer option achieves this. This option uses NUMPY's !NP. Repeat function to create the groups array. !NP. Arrange, 20, generates numbers 0 to 19, representing the 20 groups. Then, !NP. Repeat, 5, repeats each group label 5 times, resulting in a 100-element array. This ensures that all samples within each group are correctly labeled with the same group ID. This is the correct approach because it provides the correct number of group labels and assigns samples within each group the same label, guaranteeing that they'll remain together in the same fold during cross-validation. This tries to manually create the groups array by repeating each group ID 5 times. It's functional but is clumsy, error-prone, and not scalable. Imagine having hundreds of groups. It's not a practical solution. This option only provides 20 group labels, 0 to 19, whereas I need 100, one for each sample. This incorrect number of labels leads to a flawed grouping. Option A is missing the crucial groups parameter. Without this, GroupShuffleSplit cannot understand the grouping structure, rendering the stratified cross-validation ineffective. We're using Sklearn's GroupShuffleSplit to do stratified k-fold cross-validation. That means we'll split our data into folds for training and testing, but we'll do it carefully to keep similar data points together. This is useful when you have groups of data points related in some way. We want to make sure that if data points belong to the same group, they end up in the same fold. Imagine 100 data points. I've organized them into 20 different groups, and each group contains 5 data points. Think of it like sorting students into 20 teams of 5 for a project. We're trying to figure out the best way to tell GroupShuffleSplit how to split our data. We want to make sure every member of a team always stays on the same team through all the folds. This option, using NumPy's NPREPEAT and NPARANGE, is the correct one. Creates a sequence of numbers from 0 to 19, our group labels. NPREPEAT repeats each label 5 times, which matches the number of samples in each group. This gives us a perfect way to tell GroupShuffleSplit, hey, these 5 samples belong to group 0, the next 5 to group 1, and so on. This ensures that all members of the same group are always in the same fold. This tries to manually assign groups, but it's a bit clumsy and could easily have mistakes. It also isn't as clear. This approach uses, which only creates 20 group labels, not enough for 100 samples. This option misses the key ingredient, the groups information. Without telling GroupShuffleSplit about the groups, it can't perform stratified splitting, and it will just randomly assign things to folds. I'm setting up the input for Sklearn's GroupShuffleSplit function. This function needs information to correctly split the data into folds while respecting group structure. I'm telling GroupShuffleSplit that I want to create 5 folds of data. This is a common choice for cross-validation, offering a balance between accuracy and computational cost. To make sure my results are reproducible, I'm setting a random seed to 42. This ensures that each time I run the code with this seed, I'll get the same random folds. Think of it as setting a specific starting point for the random number generator. This is the crucial part. GroupShuffleSplit needs to know which sample belongs to which group. This is where I specify the group assignments for each sample in my dataset. The question is to find out which way to correctly specify these groups. After running GroupShuffleSplit, the desired output is stratified folds. That means the folds are created such that the proportion of samples from each group is roughly the same in each fold. This problem focuses on using GroupShuffleSplit, a scikit-learn tool, for a special type of cross-validation. I'll need to make sure that data points from the same group end up in the same fold during cross-validation. This is important to avoid data leakage and get reliable results. The goal is to choose the correct way to use GroupShuffleSplit for stratified k-fold cross-validation. I need to find the option that ensures samples within the same group always end up in the same fold. Think of it like organizing a team. I want to make sure all members of a certain group are always on the same team. I have 100 data points, and they are organized into 20 different groups, with each group containing exactly 5 data points. This is key information to determine how to use the GroupShuffleSplit function correctly. The most important rule is, all the data points in a single group must always end up in the same fold during cross-validation. This is essential for proper stratified sampling, which is the technique used in the question. I'm using _random_state equals 42 . This is a setting that ensures I get the same results each time I run my code. It's like a seed for my random number generator. This is to make sure that the comparison across different options is fair. I want to split my data into 5 folds for cross-validation. This is a standard approach for evaluating the performance of a model. 5 folds mean that I'll have 5 different iterations of training and testing. This reinforces that we will have 5 separate folds in the cross-validation process. We're using GroupShuffleSplit from scikit-learn, a powerful tool for cross-validation when your data is divided into groups. The goal is to make sure that all data points within the same group end up in the same fold during the cross-validation process. This helps to avoid data leakage. I have a dataset. It contains 100 data points which I want to organize into 20 groups. Each group will have exactly 5 data points. This is an important detail because my cross-validation technique needs to consider these groups. I need to choose the correct way to set up GroupShuffleSplit to guarantee that all samples belonging to the same group are always assigned to the same fold during cross-validation. I have 4 options to consider. This option is incomplete because it's missing the crucial _groups parameter. Without telling GroupShuffleSplit about the group structure, it cannot ensure that samples from the same group stay together in each fold. This option uses range 20, which generates numbers from 0 to 19. This creates only 20 group labels, 1 for each of the 20 groups. However, I need 100 labels, 1 for each of the 100 samples. Therefore, this option does not work because it does not match the number of samples in the dataset. This approach tries to manually assign group labels, but it's tedious, prone to errors, and isn't efficient. Imagine having thousands of samples. This method would be impractical and error-prone. Also, there is a problem in the specification. It must repeat each group label 5 times instead of just adding it. This is the correct option. _np. Repeat, np. Arrange, 25. Creates a numpy array of length 100. It repeats each integer from 0 to 19 exactly 5 times. This perfectly represents the group structure of my dataset. Each group of 5 samples gets the same group label. This makes sure GroupShuffleSplit keeps all samples in the same group together during cross-validation. I'm using stratified k-fold cross-validation because I want to ensure that my folds have a similar distribution of samples across my groups. This helps prevent bias and creates more robust model evaluation. This is important in situations where samples are naturally clustered into groups and I want to avoid data leakage during cross-validation. I'm trying to find the correct way to use scikit-learn's GroupShuffleSplit to make sure samples from the same group are all in the same fold during cross-validation. I've got several options, and I want to select the one that guarantees this condition. I have 100 data samples which are organized into 20 groups. Importantly, each of these groups contains exactly 5 samples. Understanding this group structure is key to selecting the right GroupShuffleSplit configuration to ensure that my cross-validation is done correctly. This option uses NumPy's repeat function to create the groups array. NP. Arrange 20 generates numbers from 0 to 19, representing the 20 groups. And NP. Repeat 5 repeats each group label 5 times, creating a 100-element array. This perfectly matches my data structure. Each group of 5 samples is assigned the same group number, ensuring they stay together during splitting. This is the correct answer. This option tries to manually create the groups array. While it could work, it's lengthy, prone to errors and typos, and wouldn't scale well for larger datasets. It's not the best approach because it's verbose and inefficient. This option only gives 20 group labels instead of the 100 needed. GroupShuffleSplit needs a group label for each of my 100 samples. This option will not work because it has too few group labels. This option is missing the crucial groups parameter. Without this parameter, GroupShuffleSplit ignores the grouping information and conducts a simple shuffle split, possibly leading to groups being split across different folds. This is the worst option. We're tackling a problem involving stratified k-fold cross-validation, a technique used to evaluate machine learning models fairly. The crucial addition here is the use of GroupShuffleSplit, which ensures that data points belonging to the same group remain together across all folds. This is important to avoid data leakage, accidentally introducing information from the test set into the training set. I have a dataset containing 100 samples. These samples are already divided into 20 distinct groups, with each group comprising exactly 5 samples. Think of it like having 20 baskets, each containing 5 apples. We need to pick the right way to set up GroupShuffleSplit to ensure that all apples within a single basket always end up in the same fold during cross-validation. The goal is to create 5 folds. This option uses NumPy's nprepeat function. Creates a sequence of numbers from 0 to 19, representing our 20 groups. Repeats each group label 5 times, matching the 5 samples per group. This creates a group array of length 100, perfectly aligned with our 100 samples. This is the only option that correctly assigns group labels to each of the 100 samples, ensuring each group stays intact across folds. This option only provides 20 group labels, 0 to 19, using Python's range function. We need 100 labels, one for each sample. This tries to manually list the group assignments, which is cumbersome and error-prone. Imagine doing this for a much larger dataset. This option completely ignores the group information. GroupShuffleSplit will shuffle samples without considering the group structure, which is precisely what we're trying to avoid.